Hello everyone, this is Dr. Shalini Arora. I got the opportunity to discuss a small topic of chemistry, and that's why I'm taking general organic chemistry, the basic principle of the organic chemistry, where we are going to discuss about the stability of cation. And as I have a very limited time period, I will be trying to discuss the application part of the cation stability, which will be applicable for your definitely for your NEET examination and for your board examinations as well. So there is one common question which you will be definitely finding in your board examination, simultaneously in your NEET examination, from haloalkanes chapter, and the another will be definitely from your alcohol ether phenol chapter. So I will take questions one by one. So let's start with question number 1. Bacho, there is a very common question which used to come from haloalkanes. The question comes like this: tell the solubility or reactivity of following haloalkanes. I'm writing in the limited words. Now class, you know, when we talk about haloalkanes, we're talking about carbon with halogen. And when we talk about carbon with halogen, definitely when we're talking about the reactivity or hydrolysis, definitely this bond will break carbon with halogen. So let me quickly write the options here. Option number A is, I'm just trying to cover all the kind of options here so that you will understand the concept in one go only. So these are the halogens with carbon I have taken, right? Okay, moving further. So if the question comes like this, which halogen will move fastest or break fastest? Bachcho, I hope you remember bit of the concept of electronegativity. Whenever we talk about carbon with halogen bond, which is more electronegative, and in my words it is which is more smarter. We all know halogens are relatively more smarter than carbon. So when we elaborate electronegativity in future, definitely I will tell this. So here halogens are relatively more smarter than carbon. They will take away the electron of carbon. So if the bond will break here the bond will break like this. And as the electron of carbon is gone with halogen will carry the negative charge and the carbon has to carry the positive charge. Here where we got the cation. So conclusion, whenever we talk about carbon halogen always try to break the bond and think if the cation is forming, what will be the which kind of cation will form. And we all know cations are not stable, right? Cations are not stable because cations are electron deficient species. But because we are making cations here, we will check the relative stabilities of all the intermediates here. Okay, so what I am doing quickly one by one, I am breaking the bromide ion here and simultaneously I am making the carbocation in all the options. Bromide ion everywhere will form and simultaneously different of cations will form. Yeah, and I hope few of you remember the name of this ion. If you don't, please start learning from now. This is troponium ion. Okay, so these are the ions which will form. Let's quickly come to the next part. What we have to check now, we have to check which cation is most stable. I know cations are not stable, but again we are talking about the relative stability. Bachcho, do we have resonance here with this cation? Yes, we have. Let me quickly tell. Plus single double single double single double. Yes, we have resonance in this entire system, but yes, every resonance thing is not stable. Here, according to Huckel's rule, this is anti-aromatic. You remember when we have 4 electrons in a system or 4n electrons in a system which are revolving in resonance, this system is anti-aromatic. It is highly unstable system. Okay, so do you think the reaction will move forward? No, it will never try to move forward because anti-aromatic things are not stable. So this reaction never exists. So can I say A will come at the last? Clearly, A will never happen. So if I talk about the stability or reactivity, A will never break. It's a passive compound, right? Coming to the another point. Let's come to the Br. Here the cation, do we have resonance? No. No sp2 hybridized carbon, no pi bond. All the carbons are sp3, so no resonance. Non-aromatic. Here, do we have resonance? Yes, we have. Plus single double, plus single double, but here we have also sp3 hybridized carbon, so this is also non-aromatic. So bachcho, both are non-aromatic, but this has resonance and the B wala part has no resonance. Coming to the D, do we have resonance here? Yes. Plus single double in the entire cycle. Yes. How many electrons are revolving in the ring? 4, 5, 6. 6 electrons always make a compound. You remember the benzene, right? Everyone know the benzene, right? So this is aromatic, and bachcho, we all know aromatic is the most stable one. So if I compare A and D, who will dissociate fastest? D will dissociate immediately fastest, right? So D will be highest, A will be the least. Trust me, in NEET examination, you will get only one option with this sequence. But sometimes it happens, we are not that much fortunate, so we should do all the practices. Let's come to B and C. But out of B and C, which is more stable? C is relatively more stable than B. So this will be the correct reactivity order of these cations. I hope you understood this question. I am just taking one more question just to save like this particular kind of questions in one go. I am clearing the board. Okay, one more question which comes here is from alcohol chapter. What is this question? Again, the question is, which of the following will give SN1 reaction fastest? Now, what is SN1 reaction? Bachcho, when we talk about alcohols, carbon with OH, when we take out the OH minus and create carbon plus, this is what we call the SN1 reaction, right? Or one more reaction can form here, one more question can form here is where OH ion is most basic. Where OH ion will break fastest. So both the questions can come. I'm just quickly marking one option here, one question I'm just giving to all of you. Let me make like this. This is my option number 1. This is my option number 2. And just to save my time, I'm taking only one more option. Yeah, I have time. Option number 3. So here, if we just consider again carbon with OH bond, and what I am adding in these reactants, I am adding H+. Yani, I am putting acid-base reaction here. I am taking B type of question where OH is behaving as a base. So if I am adding H+, H+ will attack on OH minus. If OH minus will gone from here, what we'll be getting? We'll be getting a cation. And one more concept of life, add positivity, you will get positivity. So when you are adding H+, you will get the cation left. Similarly, another cation will be this. And finally, what is the last cation? Last cation will be this. So these are the 3 different type of cations will form. Quick analysis, which cation is most stable? If I compare first, non-aromatic. Second, anti-aromatic, right? Worst example. Last, aromatic. Which will move fastest? Definitely third will be the super fast reaction. It will go fastest because we are getting a stable cation, relatively stable cation. Then second will be the worst one. It will never happen. Then who left in between? First will left in between. So second is passive, third is fastest, and this will be the correct order of the reaction. I hope you understood and I hope you like the session. I have very limited time, so I'm just cutting this off. Thank you very much for joining. Hopefully we'll be meeting again. Thank you.